All right, it looks like it's working this time. All right, so and it's doing that again, middle of the course. All right, so the problem with the one thing on heavily turbocharged engines, high amounts of boost, you're going to make the cycle much more efficient. That's where we're going for, right? That's where the drive is. The problem with that, higher temperatures and higher pressures to get you that higher efficiency, combination nitrogen oxides, right? The reason they call it NOx, it can be NO1, NO2, NO3, right? But nitrogen oxides are a common component of smog. And it is one of the major criticisms of diesels. So on, the one detriment to go into this high amounts of boost is higher NOx productions out of the engine. So then you're looking at, do we treat this internally or externally, right? And one of the things, I don't know if you had noticed, but in California, diesels were outlawed for quite a while, right? They were even talking about outlawing them for dump trucks and for city vehicles and that kind of thing. You're seeing that come back now because of after treatment. Like the one is the TDI with the Volkswagen and Mercedes. That is using a selective catalytic reduction where it is using a reaction to break the nitrogen away from the oxygen, and the output is pure nitrogen and water. Okay, but again, this is one of the things about the smog, about these new pollution controls, is if you do not use the approved components in your fuel injection and combustion system, and a lot of times that includes all your mechanical fuel injection systems, your tips, your plungers, your barrels, the head, the cover, piston crowns, valves. They have a number stamped on them for the approval. If you're taking and using parts that are not approved in that system, you can be held criminally liable. I think they were also trying to go after the office and those who are ordering the parts, which is where you would think this would come from, right? But I have specifically been told in putting parts into a system that is not approved by the manufacturer, you can be held liable, you can go to jail.
So is that why they have people come onto the ship and do all the repairs?
No. And that's only certain companies do that. The major, he was asking about people coming on. What happens is to do repairs. When they sell the engine, some of the engine manufacturers sell them, or they all will do it if you want to pay for it, a maintenance contract. One of the worst things that's happened to the American seaman. Because what ends up happening is you don't know your own ship, you don't know your own repairs. Murphy's Law says it will happen out in a storm under the worst possible conditions if you never pulled a piston before. By the way, I worked for Sealand part of my career, and one of the things that almost all the ships I've been on for most of my career, we did all the maintenance work ourselves. And I forget exactly the sequence now, it's been a few years, but I think it was Matson when they built their new ships. They would not put their own chiefs on the new ships because they weren't buying a maintenance contract, so they were taking Sealand chiefs over their own people because, and specifically they said, you haven't done the work, you don't know how to do the maintenance on these engines. Oh, come on here. All right, so that box stuff. So you're broken up into your exhaust is going to be nitrogen, oxygen, carbon dioxide, water vapor, carbon monoxide, oxides of sulfur and nitrogen. Now, again, tend to burn residual fuels with up to 5% sulfur. That's actually, I think the law has been changed now. It's 4% worldwide sulfur. When you burn fuels that have a high sulfur content, right, that sulfur remains in the exhaust gas. You will always have some moisture in the exhaust gas too. If not, it will combine up in the atmosphere. Agreed? And what is the result of that? Yeah. Sulfuric acid, acid rain. There's no way around that. There's no fix for that within the engine itself. The fix on sulfur is low sulfur fuels, right? On the oxides of nitrogen, again, that's NOx. That can be done both internally and externally. And it is done both ways, right? Or inside the combustion chamber and as after treatment. Hydrocarbons and partially reacted and non-combust hydrocarbons. Particulates is the other word for that. Where do you obviously see that in the output of a diesel? Black soot out the exhaust. By the way, is that the most visible pollution that you see?
Probably.
Yeah. And that's the one that people key in on the most. Now, on this, it's just looking at the amount of CO2, the amount of NOx, SOx, sulfur oxides, and your total emissions. One thing is I'll say that also with heavy fuel oil, heavy residual fuels have a very complex hydrocarbon chain that it is hard to break down. With residual fuels, you will have a lot more particulates, even with the best running engine. All right? You're going to have to clean your turbos once a day. You're going to have a lot more problems as far as plugging up of the exhaust valves and your waste heat boiler. Right? There's a lot more particulates that are involved in that fuel. You can go to a certain extent with the engines themselves by modifying the combustion process. But in the end, a lot of these reducing the pollution from these engines does come down to burning a clean fuel. Including, which we're just starting to see now in the United States. There's 18 ships on order in the United States. And there's at least 6 to 8 of those, probably more, that are being built to run on dual fuels, which they mean by gaseous and liquid fuels. And if you're talking of a gaseous fuel, what are you talking about? LNG. To get the compressed, liquefied natural gas if you want to get the volumes. Interesting enough on that, the diesels, it's not very difficult to convert these diesels over. You can take, like I went to a symposium with Burmeister Wayne, they can take any of their big slow speeds, and I think the medium speeds too, and you can put a conversion kit on them to burn natural gas. It's not even that expensive. On this though, there's Wärtsilä and Burmeister Wayne, the two major companies, have taken a different track on this. With Wärtsilä, they've actually converted more to an auto cycle with a spark plug. So you bring in the natural gas mixed in with the fuel, right? Just like you do on your automobile, and then it's compressed and you have a spark plug to ignite it. And they call that low pressure ignition. Burmeister Wayne has gone the opposite way, and you are injecting gas through an injector. And the problem with natural gas is the temperatures in the combustion chamber are not high enough for it to auto-ignite. So they put in a small amount of diesel, right, as a pilot fuel that will burst into flame and ignite the natural gas. I was listening from Burmeister Wayne, and it does sound to me like it is probably the better way to go, because the problems with bringing in as a gas, in that there are certain parts of you have to be very careful ramping up loads. You have to almost go in steps. There are certain areas where the engine realms where the engine will not run in, where with the high pressure it's a non-problem according to them. Anyway, the other thing on this that's very interesting, both Wärtsilä and Burmeister Wain, what they're saying is that if primarily you're on LNG, but if your LNG system fails, you will barely even hear the change over to liquid fuels. They say you might, if you listen hard, hear a momentary slowdown, but the engine will switch over with almost instantaneously. Now, the ones that I've seen that are looking at LNG is like Tote. They're going out to Puerto Rico, to the United States. They've got the environmentally controlled area in Puerto Rico and also off the East Coast, right? And the whole United States. The other one where you're seeing the very high interest in on this is if you're going up the coast and you don't want to go over 200 miles out. Well, most of the ships going up and down the coast are not that far out. Then the LNG is a very is a very good priority or option. The problem with the LNG, though, from what they said, is it's not that expensive, that difficult to change over the engines. It's about $10 million for the fuel system. And I think they said about $8 million of that was for the tank. LNG tanks, evidently, are for liquefied cryogenic tanks, are not inexpensive, and that's one of the said that they were talking about. They were working very heavily in to try to determine tanks for this liquid fuels, that cryogenic fuels, that is cheaper. The other problem with LNG in the United States is we don't have large amounts of LNG readily available. How do we transport natural gas? In a pipeline as a gas, right? Because it takes quite a bit of energy and money to liquefy it. You have liquefaction plants. Well, if I understand it right, there's only about 2 liquefaction plants in the United States, one of them in the Great Lakes and one of them in the South. You can also, I heard, get it up around Portland. But for the most cases, they probably have to truck it to the ship to bunkers. And you will have a lot more bunkering regulations when it comes to that. But here you've got a very clean fuel, then it makes the cleanup so much easier, right? And the maintenance is dramatically less. You have a lot more maintenance when you have dirty fuels. Yeah?
What's the space limitation on that? I mean, aren't these tanks fairly large? Isn't that going to take some of the revenue down?
And you can't put them down below. So it depends on the engine design, or the vessel design.
But if it's a cargo ship, a container ship?
The container ships, what they're doing, the ones I saw with Tote, you know how the house is an after house, and then you have 1 or 2 lengthwise containers on the stern.
Yeah.
The first tier was the tanks, and then they would stack containers on top of that. So you would lose probably, you know, the beam of the ship, 1 or 2 containers aft, that amount, but it's not substantial. But it's, like I said, to put the tanks in. And to try and retrofit the fuel system after the ship was built, that's another. So nitrogen oxides contribute to the formation of acid rain. This is the big one, smog formation. The other thing on this is don't think that smog produced out at sea doesn't affect inland, right? I forget what they said of the percentage of smog here in California now that actually comes from China. And that's the argument here. You know, and I think it is a fairly legitimate argument. Yes, you're burning that fuel out at sea, but that pollution that you're producing does not stay out at sea, right? But NOx is one of the big ones. And the sulfur oxides too from high sulfur fuels. So the sulfur oxide, unpleasant odor, irritates mucous membrane, major source of acid rain. Now I don't know too, there's been a lot of talk about acidification of our oceans at this point too. More of that they're worried about with, on the bottom of the ocean, there is a lot of CO2 and methane stored as a slush, frozen. What they're really worried about is if you raise the temperature of the oceans a few degrees, and it doesn't take much, it's only a few degrees, some of that will start to gasify and bubble out of the oceans. It could dramatically change the planet. Okay? With that, with the CO2, carbonic acid, you could substantially change the pH of the ocean. Shellfish live in a very narrow range on the pH band. If we get out of that, they will not be able to develop a shell. And worldwide, we could lose all of our shellfish almost very quickly, which would have a dramatic effect on the food chain. Now, with the acid that you're dropping out from the ships, how much that will affect that, I don't know. And I don't know if they've done a study on that. Okay? But again, that would be a contributing factor. On a ship, one of these large vessels running today, you're burning as much as 200 metric tons of fuel per day. Are you a major polluter? Yes. No question about that. So the unburned is more the visible, but in reality, I think the somewhat lesser on the scale as being harmful, though it's very, very visible and it is carcinogenic. Carbon monoxide, CO2, again, you know, this is a contributor to the global warming and these other problems. Particulate matter comes from incomplete combustion, partly burned on lube oil, thermal splitting from the fuel in lube oil, ash in the fuel. And again, most of it's going to come up as, you'll see it as solid carbon. Now, one of the things we're getting into, and Tier 1 is already passé. And by the way, this talk is a very, very good discussion in pounders. And again, I assigned that as reading, and I would read it. But you're going to Tier 1, Tier 2, and Tier 3, right? This is like the automotive industry where they're phasing in smog emissions over time, right? Okay. In fact, we got new engines on our boats in the harbor through this. The state of California gave us grants to take out the old polluting engines and put in newer, I think they were Tier 2 or Tier 3. I think they were Tier 3 engines into the bear to reduce the pollution. So you notice 2010 is the end of this scale. But anyway, what we're trying to do is also reduce NOx. Now, on this, where I want to, is this one, is the battery dead? Okay, I don't know, for some reason. So, one thing on this is to substitute your fuel. And I think it is a good option to go to LNG, burn a clean fuel out at sea. I would make a definite argument that residual fuels should be burned shoreside in shoreside power plants because they're more readily able to deal with the problems of it, right? PG&E can, like with the sulfur, they do a scrubber. You can scrub the sulfur out, then I think you mix it with, if it's limestone, anyway, they put them out in leach fields, and the byproduct is gypsum. So they can treat that. You can put in particulate filters, all of these things that would make your life a living hell on a ship, right? So we'll see what happens, but one of them is either to go to clean low sulfur distillates or LNG. The interesting, again, I kind of warned you about that. There's many people that get upset about this whole fuel changeover because it's outside the norm. Right? So you kind of want to listen. But understand that when you're talking about these big ships out there, and look out how many ships are out there, again, burning 200 metric tons of fuel a day, they are a major polluter. There's no question about it. And switching over to clean fuels, would it have an effect? Yes, especially when you talk about somewhere like Los Angeles with a big port. Though I don't necessarily agree with shutting the ships down and switching over to shore power. All right, so internal treatment. You can do emulsified fuel, and when you look at our trainer, it has that option with the Burmeister Wayne. You can emulsify some water into the fuel before you put it into the pumps, which is really hard for my generation because we were always brought up that water in your fuel will take out your fuel pumps, right? But with this ultrasonic emulsification, it's bonded well enough to the oil molecule that you don't get into that problem. You can do as much as, I think, 25% water or something like that. Now, why would adding water into the fuel and injecting that water into the cylinder, why would that make your emissions better? You're right. It's a refrigerant. As it changes state, it's going to pull in heat, and it's going to drop the temperatures in the cylinder, which will drop your NOx. What does that do to your efficiency, by the way? Lowers it. Lean combustion. This is very common. You will see a lot of the engines designed to run lean to lower the pollution levels of this. Rich combustion, I don't think you'll see. Combustion chamber design, pre-chambers, fuel valve modification, this is the big one. And actually the combustion chamber redesign is a big one. Very high pressure fuel injection because you get better atomization. On the scavenging air cooling. If you cool the air coming in, it'll make it more dense, but it also would tend to, by the way, this is more of, is this, let's see, yes. There's, in some cases, they're actually spraying a mist into the incoming, after the charge air cooler, they're spraying a fine mist that goes into the engine. Humid air motor, they call it. Makes me very uncomfortable with heavy residual fuels to do that. But again, just like emulsifying it with the fuel, that would lower your temperatures. Water injection into the cylinder. By the way, this is not a new idea. This was done, I think I mentioned to this class before, this was done in World War II with a high altitude escort. And I would imagine they probably did it with the bombers too, but the ones I've seen it, I know the Mustangs and the P-38s had it. At high altitude, they were getting pre-combustion, or pre-ignition. So they had water injection to keep the fuel air mixture from exploding. Same thing, this will reduce the temperatures. Cycle modification is another one. In exhaust gas recirculation, you're going to see, just like your car has an EGR on it, you're going to see that on the ships too. And then post-treatment, SCRs. I think that's going to be real big. This shows you how much you can reduce it. And the SCR by far is the best. But I think you're going to see some combination. One of the problems with the SCRs is that they only work when the engine's up at high loads. When you drop the load off, the temperature is not high enough, and it needs that temperature for the catalyst to work, right? So likely you might have one of these other types to reduce the NOx at low loads and an SCR for high loads. You also will always see the SCR after the before the turbos, which is going to, since they do take some of the heat out, is going to affect your turbocharger output. With direct water injection, they actually have an injector. Sometimes it's combined in the same injector, sometimes it's a separate. but that what it does is it injects water directly into the cylinder to lower the temperatures, and that will also lower the pressures. I put this in just to show you that we have on the simulator, here's your freshwater emulsion control. And you can try it and play with it. I haven't played with it too much. And here's the humid air motor, where they'll take it and literally humidifying the air. They've got a compressor, so you're taking hot compressed air and humidifying it and then injecting it into the intake, the scavenging air going into the engine. Again, doesn't make me warm and fuzzy with heavy residuals. It wouldn't bother me too much with a low sulfur. Exhaust gas recirculation. The problem with exhaust gas recirculation is we have to put a scrubber in it, because if we're burning heavy residual fuels, you have a lot of particulates in there. You got to clean it up. So what you're doing is you're bringing in the exhaust gas, and you've got typically of trays of rock or like ping pong balls and spray nozzles, right? And it's having to work its way up through that to clean it. And then that cleaned exhaust is fed back into the scavenging air system. And you're feeding that back. And that's been used for a long time with automobiles. Exhaust gas recirculation has been around since at least the 70s or 80s. Okay. One of the problems of doing this, though, with high sulfur fuels is now you're going to be dumping a lot of sulfuric acid directly into the ocean unless you treat it. And if you treat it and neutralize it with a base, now you've got a toxic sludge that you have to discharge from the ship. So SCRs, and in lesson 6 we'll get into the SCR. You've got a good depiction of an SCR on the simulator. You've got a, if you want to call it that and put it in common terms, you've got a catalytic converter, right? Right? It's a catalyst. And it is in the exhaust stream. You bring it up to temperature. The exhaust gas goes through it, and it looks like a honeycomb. They have a definite life. It's something like about 30,000 hours, but they have a definite life, which is shortened, by the way, if you plug them up with a lot of particulates. They're not acceptable, really, for heavy fuel oil. I don't really think you're going to see them on heavy. You'll have to be burning clean distillates. It's just plug up too fast. And you inject ammonia. It's usually called, what they're saying is urea. Urea is a dilute form of ammonia, and it may come basically from, I don't know if that's true or not. You'd have to look it up, whether it's the same concentration as urine. I don't know. But it is usually comes in a powdered form, which is much easier for the shipboard for you to deal with. Right? You take that powdered form and you mix it into water, and then that is sprayed. And ammonia is made up of nitrogen and hydrogen, right? As that ammonia goes into the catalytic, under heat and the catalyst, it breaks the nitrogen away from both the nitrogen oxide and away from the ammonia molecule, breaks it up. The nitrogen, pure output, the oxygen and the hydrogen combine, and you have water. Oxygen and water, nitrogen and water output. And you can take the NOx down to whatever levels is mandated by law by injecting more of this ammonia. Now, the one thing you've got to worry about this, though, is if you go too far, you get what's called slip. The ammonia, if it's not reacts and not broken down, leaves with the exhaust stream, and then you're putting ammonia out into the atmosphere, right? Which nobody wants, because one, that's a pollutant in and of itself, but the other one is, you're wasting money, right? Now, on selective catalytic reduction, we've been having ships coming into the Bay Area for years now, probably for about 5 to 10 years. There's actually one, if you go over to Pittsburgh, there is a plant that produces steel for like tin cans and different products. Their ship, when it comes in, is run under Maersk, has a crew come on it when they pick up the pilot. They set up the exhaust gas monitoring, And they monitor the emissions from that ship all the way over to Pittsburgh while she's sitting at the dock at Pittsburgh and all the way back out to the pilot outside of San Francisco where they get off. And that vessel has an SCR. The pollution from that ship was tied into the pollution index for that plant, right? And so, like I said, this is something that your generation is going to be more and more of, right? We'll see what happens. It's all going to be dictated by law. But again, the problem with it, it doesn't really, see, they're coming into California 200 miles out, and then they're putting the SCR on probably out right before they pick up the technicians, and they're burning clean distillates when you're doing it. You're not going to do it in fact, in the lesson 6, I kind of have you do it while you're changing over. And in real life, you'd probably wait till you're fully changed over before you went over to the SCR. You'll just plug it up with all the soot from heavy. So a lot of the SCR is fuel dependent, and if we're running heavy, you're not going to use the SCR. They're talking, the weird part about with all of this is, and it's actually okay with the California Air Resource Board, there is a loophole in the ECA, Environmentally Controlled Area legislation worldwide, that states if you put a scrubber in and scrub the acid out, then it's okay because your air pollution is not bad. What's the problem with that? You're making acid rain directly. So and they don't necessarily in the legislation say that you have to treat it. The Europeans have been the ones proposing that you will neutralize it with a base. A lot of other countries I've seen have just said, well, we'll just dump it in the ocean directly. And again, you know, I mean, some of this really does need to be well thought out because it's not my generation that's going to be affected by this. It's going to be your generation. But if we crash the food chain to get us our Nikes 5 cents cheaper, does that make sense? And again, you know, my argument on this is if this is, you know, why are we burning the dirtiest fuel possible out at sea? It makes the life of the merchant seaman very difficult. The closest I've come to going aground with a fully loaded tanker, the biggest problems I've had out at sea have not been mechanically orientated. It's been fuel problems. And the fuel is getting worse every single year. So, you know, I would basically argue if it's worldwide legislation, right, and everybody has to switch over to clean distillates, and everybody's doing it, then that cost is put out to the consumer, and it'll be, you know, a dime more for your tennis shoes or something. It's, you know, what are we doing here? Why are we doing this? But anyway, that's a very hot topic, and you want to listen rather than wade in because you'll get your head handed to you. When I gave this with the fuel changeover, I went to 3 or 4 meetings with a lot of people there, both 2 at the Coast Guard and 2 with the California Air Resource Board, on discussions on this, on changing over 200 miles out with the fuel changeover regulations. I can tell you there was a lot of hot people in the room, and I was very, very careful what I said and what I did. And it's not worth getting into the argument with people. It'll all be mandated by the federal government anyway, right, international. But what I have seen is the discussion is phasing heavy out in 2020. And again, the new fuels you've got is nothing like the fuels the fuel in the 1970s was great fuel. And the other thing that was funny on the steamships, if we had water in the settlers, we'd open up the low suction and pump over the side for about 3 or 4 minutes to get rid of the water. Have time changed. And think about it, is that stupid? Right? I mean, it was a waste of a resource, wasn't it? But that's what we did back then. That's the way I was taught of how to get water out of the settler. Pump it over the side. You get thrown in jail for that real quick today. In fact, that's the other one. Most ships now, even with their bilge water, clean bilge water, they're holding it on board just because the regulations, you're so liable today. Be very, very careful how you fill out paperwork. right? Cannot filling out the oily water record book throw you in jail. Even if you do it correctly, if you improperly put it down, there's a good chance that they could come after you. And they're measuring, they're looking at your discharges. By the way, the other one on the discharge over the side, we used to kind of guesstimate, right? You better make a pretty good estimate on what you're discharging today, because they are going back through all the records to determine what your water output should be. And specifically, too, if you say that you pumped so much water over the side and in excess of the bilge pump's capacity, which is real easy to do because a lot of them, you know, are not very high capacity, right? They will come back at you directly, and if you signed that, by the way, guess who they're going to come after?